I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Hi, I'm Professor Pi. And today, as you can tell, we're going to talk about triangles. We're going to talk about triangles. But before I talk about triangles, let me know what you know about triangles. You've seen triangles ever since kindergarten in that workbook. You had problems like 5 plus triangle equal 1. I realize that's more like algebra than geometry, but you've seen triangles most of your life. So I'm going to send you a Google Doc. You're going to write down everything you know about triangles, and then we'll talk about triangles. Hi, Professor Pi wanted me to remind you about the rules about a Google Share Doc in this classroom. Everything you write's got to be about triangles. It doesn't have to be correct, but it's what you think about triangles. Don't do what I did last time and start talking about lassoing that cow. The rules are only talk about triangles. You keep sharing what you know about triangles. I'm going to bring them up one at a time and talk about them. Remember to share whatever you think you know about triangle. I'm hoping at the end of this lesson that most of you already know everything that I was going to teach you about triangles today. I'm going to bring them up one at a time. There's one. A triangle has 3 sides. And octagons have 8 sides. And squares have 4 sides. That's the beginning. What else do you know about triangles? Oh, there we go. If it's got 3 sides, it's also got 3 angles. One of you know something about the Pythagorean theorem? A squared, B squared, C squared. Apparently you know that you've used that on a triangle before. What kind of triangle did you use that on? Somebody just said it. You use it on right triangles. The Pythagorean theorem does not work if the triangles have a bigger angle than 90 or a smaller angle than 90. So if you have a right triangle, the Pythagorean theorem says a squared plus b squared equals c squared, and c is what we call the hypotenuse. The hypotenuse is the biggest line in the triangle, and it's always across on the right side. Very good. Now, what else do you know about triangle? Some are equal all the way around. We call those equiangular, and we also call those equilateral. Equiangular means all 3 angles are equal, and equilateral says that all 3 sides are equal. Most people use the word equilateral better or more often than the word equiangular, but it's the same word. An equilateral triangle has 3 equal angles. And all around, triangles aren't round. So let's rephrase that. Some are equal on all sides, because all around really doesn't work for me with a triangle. 3 equal sides. We call that equilateral. Equilateral. And you know how Professor Pi is with spelling. You know how most mathematical teachers are with spelling. Somebody check that. Make sure I spelled it right. We call that equilateral. Yep, somebody checked it because I didn't spell it right, but what you do to correct your spelling on the Google Doc is you go right up here, you click on the word that has underlined in red, and you click right there, and it tells you what you think the word is, and if that's the word, it just changed it for us. That's how you correct your spelling on these Google Docs. Some are equal on all 3 sides. 3 equal sides. We call that equilateral triangle. Let's see what else you know. Some have a right angle. Yes, they do. And we've talked about right angles. So let's put that up here with the Pythagorean theorem and right angles. We can have a right triangle. A right triangle has one right angle. We have equilateral. That is, equilateral triangles are equal on all 3 sides. And if they're equal on all 3 sides, there's 180 degrees in a triangle. How much is each angle? Right, 60. How'd you get that? She says she divided 180 by 3 and got 60. Very good. Says some angles are big and small. All right, let's start with the small ones. Some are smaller than 90 degrees. What do you call those? The small ones, small angles, that is below 90 degrees, not exactly 90 degrees is right angle, right? We've got that up here. So we're going to say that's exactly 90 degrees. What would the small ones be? Small ones would be less than 90 degrees. And we call those angles acute. And then we have some bigger angles. Bigger angles are going to be bigger than 90 degrees. I can't spell degrees, apparently. You see what the red is? The red means I misspelled something. Go back up and fix that. Oh, 2 E's in degree, thank you. What do we call big angles? You've never heard that word? What do we call angle from chapter 1 that's bigger than 90? We call it obtuse. So what do we call this one? We call this one obtuse triangle. We have obtuse triangles. We have acute triangles. We have obtuse triangles. I think we got this now. We got all the stuff about angles. How big can the angles get? How big can the angles get? They can get below 90, right? They can get bigger than 90. We'll put it down here, organize this stuff, because you people have all put it in different places for me. But you're getting the right answers there. And then we want this one to be 90 degrees. Think about it. Is there any other way we can have an angle? We can have a small angle, a right angle, a big angle. Does that cover it? Yeah, those are the 3 words that I wanted to teach you today about angle sides. Acute, are we talking about sides? No, we're not talking about sides. I'm sorry. We're talking about angles. Angles can be right, angles can be acute, and angles can be obtuse. What else did you tell me about? 1/2 base times height. Somebody actually in the class actually knew the area of a triangle. Very good. That's the area. 1/2 the base times the height. What else did you know? There's 180 degrees inside a triangle. I think we had that in class the other day. I'm glad somebody wrote it down. Some have 2 equal sides. So now we've talked about the angles. Let's bring that one up here. 2 equal sides. We've already talked about a triangle that had 3 equal sides. So let me bring it down and put it down here. This is equilateral, EQUILATERIAL. And that's wrong. What's wrong with it? There's no I in equilateral. A lot of people make that mistake. We correct it. There we go. That's it. Now, equilateral was 3 equal sides. Some have 2 equal sides. Yes, they do. And we're going to call those isosceles. ISSOCELES. And that's not right. What's not right about it? I think there should be another O in there. Does that look like isosceles? Isosceles, spell it the way it sounds. Let Google Doc take care of it. ISOSCELES is the proper spelling there. And that's one of the words I wanted to talk about today, so we'll highlight it. And then equilateral. All right, I can get 3 sides equal. I can get 2 sides equal. I'm looking. I don't see that great piece of wisdom here. All right, somebody figure this out. If you can have 3 equal sides and you can have 2 equal sides, you can also have the last one would be no equal sides. I can't believe I had to come up with that on my own. One of you should have shared that with me. By the way, we have a word for that too. It's called scalene. 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 No 2 sides equal. Where's the highlighter? The highlighter's right here. This is the text color. The highlighter's right up here. I don't highlight much, but I highlighted your vocabulary words today. All right. I'm going to continue teaching the lesson, but I can tell you something. With your group share, I'm pretty sure you know most of this. It's just a matter of a few vocabulary words that we're going to use. But you have the idea. This is classifying triangles. G.co.12. I can identify and classify triangles by their angle measure and by their side measure. My video, when we're done with this, will go right there. I've given you 4 other videos. If you don't get anything from mine, please go to one of those videos to learn the concept. I've also given you something called the triangle song, and we'll play that for you in class. It's a catchy little tune that might actually help. We classify triangles by sides and by their angles. A triangle only has 180 internal degrees. By side, we have equilateral triangles. It is marked equal on all 3 sides. All 3 sides are equal. All 3 angles are also equal. So that's 180 degrees inside divided by 3. One of you already did that. That's 60 degrees. We have an isosceles triangle, and it's spelled right here. ISOSCELES. Yeah, I know it's hard to spell some of these Greek words. 2 equal sides. And then we have the scalene triangle down here. It has no equal sides. On the other side of my chart here, I have our angles. We have acute angles. All 3 angles have to be below 90 degrees. If you get one obtuse angle, then it's obtuse triangle. If you get one right angle, it's a right triangle. Acute triangles have to have all of them below 90 degrees. That one looks like about an 80-degree angle. That one looks like about 70. And if this were 80 and 70, we could figure out the third one by subtracting from 180, right? Here's the right triangle. And one of you in class knew that we used right triangles for the Pythagorean theorem. You had that in Algebra 1 and pre-algebra. It has one right angle. It can't have two right angles because two right angles would be 180 degrees and you wouldn't have a triangle, you'd have a little box. That third line would never meet because I've used up all my angles. Then we have an obtuse angle. This looks like about a 120-degree angle. It can't have three obtuse angles and it can't have two obtuse angles. There's only one obtuse angle because there's only 180 degrees inside that triangle. And I'm going to send this chart with the lesson. So if you get confused, you can always look down at the chart for a while and figure this out. But most of you know everything. We do have some possible combinations of the above definitions. By definition, you can't get a right acute triangle and you can't get a right obtuse triangle. You can't get right equilateral. It's either equilateral or it's right, but it can't be both. You can't get equilateral scalene, which is why I struck through all those. Oh, you want to know how to cross out and strike through? You go up here to format, you go to text, and there it is, strike through. I don't know why you'd use it, but there it is. Please don't do that on a test because I'm going to grade what you strike through anyhow. There are some possible combinations. You can have right scalene. What would that look like? It would be a right triangle with three different sides in length. You can have right isosceles. Two angles equal on each side. There's two angles equal at the bottom, a right angle at the top, and the two sides would be equal. The third side could not be equal because it's the hypotenuse. But you could have a right angle. You could have a right angle and two equal sides. Acute equilateral. All equilateral angle triangles have 60 degrees. So all equilateral or all equal angular triangles are also acute. Could you have acute scalene? Yes. Up here I have a scalene triangle. It's not a right triangle, it's acute. It's acute and scalene. Could you have acute and isosceles? I think I have one up here. Isosceles, that's an acute angle, it's less than 90. That's an acute angle, less than 90. That's an acute angle, less than 90. So yes, you could have an acute isosceles triangle. An obtuse scalene triangle. You can have a triangle up here that is obtuse, and obviously this side, and this side are all different lengths. So we call that scalene. So you could have an obtuse scalene. Could you have obtuse isosceles? Yeah, an angle bigger than 90 at the top and both sides equal, just like the length of my hands are equal. That would be what the triangle looks like. So you all learned a lot about triangles before you got to geometry. This chapter should be really easy for you. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.